Hello everyone, good morning. I am Nikunj, your physics teacher from QNI, and I welcome you all to the QNI class. How are you all?
Very good, sir.
Good morning, very good, very good. So let's start today's lecture. So before starting the lecture, first we will see what are the prerequisites. Okay, we are studying the chapter friction. Yes, Chatra.
Sir, I was absent in yesterday's class, so can you just give an idea of what happened?
Okay, we will see a quick recap of the last class. Okay, okay. So first we will see what are the prerequisites for this chapter, which is force. Okay. So I hope no doubt in the force that what is force, types of force.
No,
Any
sir.
doubt? Okay. Then friction. Okay, we will talk about this about friction. So the basic idea about friction is that friction is acting opposite to the direction of motion. Yes or no? It opposes relative motion. Yes or no?
Yes, yes, sir.
Okay. Then types of friction. Okay. Now if we talk about the weightage, so approximately 7 to 8 marks question asked from this chapter. Okay. Now, what we're going to study today. So first we will see friction as necessity or evil, then loss of energy, methods of increasing friction, methods of reducing friction, fluid friction, and streamlined bodies. So these are the topics we're going to study today. Okay. Now we'll start with the topic friction. Okay, before starting the lecture, let's have a quick recap of till what we have studied in this chapter. So first we know that please tell me what is friction. Please reply. Okay, at least for 5 to
So the
10 minutes.
force,
Yes.
the force that opposes the motion.
Okay, Chatr. Chatra, are you listening?
Yes, sir.
Okay, so what is friction?
Sir, friction is the
Friction is a type of contact force which opposes the relative motion.
the
Yes or no?
yes, yes, sir.
Yes. And it is contact force. So basically, it is acting between the two surfaces of the body which are in contact. Okay,
Yes, sir.
very good. Now, after that, we studied that types of friction. There are three types of friction mainly: static friction, sliding friction, and rolling friction. Static, sliding, or kinetic, and
And
rolling.
rolling.
Yes. Now, what is static friction? So, static friction is a self-adjusting in nature. First thing, static friction is self-adjusting in nature. Okay. So, what is static friction? Okay. So, friction, if you see, if we have two surfaces, suppose, uh, one second, suppose there is, okay, wait a minute. Okay. Suppose there is a table, and on the table, suppose this is your table. Okay. And on the table, there is a block. Okay. Yes or no? This is a block and this is a table. Okay. Now here we know that block and table are in contact. Okay. Now if we see from the naked eye, we saw that the surfaces are smooth. But if we see microscopically, what we see that if this is the surface of the block and this is the surface of the table. So if we see microscopically, then we see there are irregularities between the surfaces. Okay, there are some irregularities between the surfaces like this. Okay, so there is some contact points, and at these contact points, there are some interlocking between the two surfaces. The surfaces get bonded together. Okay, now if I want to make this block move, so for that I have to apply some force. So it's not possible that just I'm touching the block or the book and that block starts moving. I have to apply some amount of force on that block to move. Okay. So suppose to start the motion of the block, we need to apply a force of minimum 5 Newton. Minimum 5 Newton. So this 5 Newton is the force which required to break the bond here. between the two surfaces. Chatra, till now, are we clear? Are you getting my points?
Yes, yes, sir.
Okay. So suppose I'm applying a force of 1 Newton. So tell me, is the block move? Will the block move or not?
No, sir.
No. Okay. So if I'm applying a force of 1 Newton, that means friction is also acting 1 Newton. Okay. Similarly, if I'm increasing the value from 1 to 2, 2 to 4, 4 to 4.999, in all the cases, block will not move and friction, static friction is like 1 Newton, then 2, then 4, then 4.999. So from this observation, we can say that static friction is self-adjusting in nature. Okay, and it is directly proportional to the applied force. Static friction is self-adjusting in nature and it is directly proportional to the applied force. But as we apply a force of 5.0001 Newton, now for this amount of force, block starts moving. Now the friction is not static because there is a motion. There is a relative motion between the table and the block. Okay, so till the block is not moving, the friction acting between the two surfaces are called static friction, and static friction is self-adjusting in nature. Okay, now there is some maximum amount of friction force which can be offered by these two surfaces, and that maximum amount of force here is 5 Newton, and we call this maximum static friction as limiting friction. We call this maximum amount of friction is limiting friction. And after that, block starts moving. Now the friction acts between the surfaces which are in motion is called sliding friction, is called sliding friction, or we called kinetic friction, static friction or kinetic friction. Okay, so any doubt till now? Anyone?
No, 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 sir.
Okay, now if we draw the graph between the force of friction and the applied force of friction, this is here I'm taking force of friction on the y-axis, and on the x-axis I'm taking applied force. So we know till the limiting friction, the static friction is directly proportional to the applied force. So there is a straight line. Okay, now there is some maximum value after which the friction force will decrease, and there is some constant value of the friction force between the two surfaces. So this is the limiting friction. This is the limiting friction. Now this proportional is static and this is kinetic friction. So I hope till now we clear what is static friction, what is kinetic friction.
Yes, sir.
Now there is one more type of friction called rolling friction. Okay, so you can see we use wheels. Okay, in trolley bags, in pulleys, we use wheels for the movement of the blocks, for the movement of the body. You know, in the well, we also using pulleys. Yes or no? So just to for the ease of the motion. Okay, because if there is a we are using wheel, so there are less contact of the surfaces. Okay, so the friction between the surfaces are comparatively less than static and kinetic. Okay,
Yes, sir.
you can understand by this example. Uh, suppose there is a heavy box. Suppose there is a heavy box lying on the ground. There is some heavy box lying on the ground, and let's say weight of this box is 50 kg. Now, if I tell you to push this block and set this block in motion, so we'll require some amount of force, let's say X Newton. Now, in the second case, what I'm doing, I'm taking again the same block. Now, at the bottom, at the bottom of this block, I'm attaching a wheel. Okay. Now, again, this block is lying on the same table of 50 kg. Now, again, I told you to set this block in motion by applying a force, let's say Y Newton. So tell me in which case the force applied by you is less, in the first case or in the second case?
This in the second case would be
Why?
because
Here, yes, tell me.
s- because there's less uh
Because here we use wheels. There is less
Yes.
contact, yes or no, between the
Yes, sir.
surfaces, yes or no. So it is easy to move the bodies with the wheels with the, yes or no. So can we say the sliding, sorry, the rolling friction is less than the static friction? Is
Yes, sir.
it is easy to move with the help of wheels rather to push it. Okay. So here both the blocks are same, but the required force to start the motion is less in the case of wheels. So now anyone having any doubt till now?
No, sir.
Are we clear? So Chatra, this
No,
all things
sir.
we discussed in the last class.
Yes, sir.
Yes, sir. Clear, sir.
Very good. Okay, what about others? Sudipti, Isabel, Rishmita, Venpa. Tell me, Povina.
No
Anyone
doubt,
having any doubt?
sir.
Everyone, please tell me. Povina, Kevin.
No, sir.
Okay, so let's start today's lecture. Okay, first we can say friction is necessity or evil also. Okay, both ways we can say. Okay, now why it is necessity? So for walking on the ground, we require friction. Without friction, we can't start motion. Okay, so first tell me, is it easier to move on the, you can say, at your home or on the grass or on the ice, where you can move easily?
I.
Ice.
Sir, no, sir. Not ice. There's very
I
less
mean, because there
friction
is
there.
less friction, we
Ice is
can
slippery,
move
na?
more.
You can't move easily on the
There's
ice.
less friction. That's why
Okay,
you
friction is
slip.
less. Yes, friction is less, but ice, if you start walking on the ice, so ice is very slippery as compared to the grass. Yes or no?
Yes, sir.
You will get skid on the ice.
Yes.
So I think it's more easier to walk on the grass as compared to ice.
But sir, isn't there more friction in glass?
That's why friction is important for walking.
Okay.
Without friction, we can't walk.
Didn't you give us three options? One is okay. Okay, get it, sir.
Sorry. So if there is no friction, we can't walk. We get skid on the ice. Yes or no? We can't walk on the ice easily. Are you getting my point or not?
Yes, sir.
Okay. So if we have to walk on the ground, so how is walking related to the friction? Okay. So see, there is a contact here between the shoe and the ground. Okay. So if I am going in the forward direction, if I am going in the forward direction, so I am pressing the ground in the backward direction. Yes or no? If I am pressing the ground in the backward direction, so as a resultant from the ground, friction is acting in the forward direction, which helps me in walking. Okay.
So can you repeat it? I did not get it. I did not get it, sir.
Okay. Just wait. Okay, you can see from here. When we are walking in the on the ground, so we are pushing the ground, yes or no? When we are walking,
Yes,
we are
sir.
pushing the ground. Okay. Now, if you are going from left to right, so in which direction you are pushing the ground? When you are
In the
going
forward
from,
direction.
no. Let's say you are going, you are going towards right. Okay. So for a minute, please try this at your room. If you are going from left to right or right to left, so in which direction you are pressing the ground? If you are going towards right, tell me. You are
Right.
pressing the ground in which
Right.
direction? Towards right or left?
In the right direction.
Towards
Right.
left. Towards left. You are pressing the ground towards left, not
How are
right.
we pushing to the left if you're going left to the...
No.
But sir, like if you're moving towards right, we are pressing towards the right ground, right?
Okay. How I will explain? Okay. Okay. You can see here. You can see this fit. You can see this shoe. Yes or no? Yes or no?
Yes, sir.
So
Yes,
if you are
sir.
going in the forward direction, so you're pushing the ground on the backward direction, na?
Okay.
So as a result, you are moving in forward direction by the Newton's third law. Okay, but for now, just remember this thing. Listen, you can see here, you push from sole of shoe on grass, and on from the forward side, you push shoe again on the grass. Okay, so when you're going towards left, so you're pushing the ground in backward direction. Yes or no?
Yes, sir.
And we know that friction is always
Okay, I get it, sir.
acting,
I get it, sir.
and friction is acting opposite to the direction of motion. Yes or no? Friction is trying to oppose the motion. So it is acting towards right, which helps you, which helps us in moving. So friction is necessary for in case of moving. Okay, are we clear?
Yes, sir.
Everyone, please confirm. Is there any doubt? Yes or no?
No, sir.
Yes, Isabel, Kevin, Chat, please confirm. Rovina, okay. So it is friction between the ground and our feet that enables us to the walk. Very good. Okay. So when we walk, we push the ground and our feet in the backward direction, which is action. And as a reaction, friction then provided the forward reaction and makes us move forward. Okay? Yes or no?
Yes,
Is
sir.
this clear? Okay. So
Yes.
if friction between our feet and ground were absent, it would not be possible to walk, as in case of ice, because between if we are walking on the ice, so ice is providing us less friction, which makes us difficult to walk. That's why when we walk on the ice, most of the times we keep on skidding, not walking.
Yes,
Okay,
sir.
is this clear to everyone?
Yes.
Isabel,
Yes,
any
sir.
doubt?
Yes.
Isabel, any doubt? Okay. So please remember, don't get confused that while walking on the ground, we are pushing the ground in the forward direction. No, we are pushing the ground in the backward direction. And as a reaction, friction is acting opposite, that is in forward direction, because of which we can walk on the ground. Okay? Okay. Next, for rolling. Again, for rolling, friction is very important. This is similar as in case of walking. Okay. So in case of rolling, again, you can see the friction between the tires or wheels and the road is necessary for vehicles move safely. Okay, because if friction is less, again the tire is not rotating, it's skidding. You can see if we are in mud, so in case of mud, tire is rotating more, not moving. Yes or no? Tire is rotating more, not moving in the forward direction or backward direction. Yes or no?
Yes, sir.
And in case of ice, again the tire is not rotating more, it's skidding more. So for a perfect motion of the bicycle or car or bike, we require some good amount of friction. Okay, because of which tires can rotate or tires can roll. Okay, so if there were no friction, the tires of vehicles will go on spinning at the same place and will not move forward at all. Yes or no? So if the
Yes,
friction
sir.
becomes less than a specified value, the wheel tire can lose their grip of the road and they will start skidding. Sometimes if we apply brake, then what will happen? We skid. That time tire is not rolling, tire is skidding. Yes or no?
Yes, sir.
Are you getting my point? Is there any doubt?
No, sir.
Everyone, others, please confirm. Yes, Sudipti. Any doubt, Rishmita? Yes or no? Okay, very good. Now, the third one is performing small day-to-day activity. The first one is writing with a pen or a pencil on the paper is possible only because of friction. Because if friction is absent, then you cannot write in a particular direction. Suppose if you are writing in any direction, so suppose there is no friction, so I keep on skidding. I cannot change the direction. I can change the direction because of the friction. If friction is so small or absent, I cannot move in which direction I want. If friction is less, I will start skid in a particular direction. Yes or no? Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Now, why it is not required? Because friction sometimes act as a evil. The first one is loss of energy. So because of friction, there is losses of energy in case of machinery parts. Okay, many a times. Okay, friction consumes sustainable part of the useful energy available to us. Okay, a friction up because friction opposes motion between two objects in contact. So some of the energy to move the object is wasted in overcoming the friction. Yes or no? And you also feel this. Sometimes you can see the engines get heated up. Why? Because there some machinery parts involved, some machinery parts are tied together. So there is some relative motion between the machinery parts because they are in contact. And because of the contact between the surfaces, there are friction. And because of friction, friction is opposing the motion. Okay. So because of which that body parts get heated up, that machinery parts get heated up, and there is loss of the energy to overcoming the friction because friction is opposing the motion. Yes or no? Sometime it is good, but sometime it is bad. And I'll tell you, most part of the friction is good. Okay? Is this clear? Yes or no?
Yes, yes, sir.
Okay. So suppose there is a car moving on the road. So only a part of energy obtained from its fuel is used up in running the vehicle. Okay. So major part is wasted in hitting the machine, friction between the ground and tires, and sound produced. Yes or no? Sometimes we see the engine parts get heated up. Okay. Now, friction consumes a sustainable part of the useful energy available to us as friction opposes motion between two objects in contacts. So some of the energy to move the object is wasted in overcoming the friction. So a significant amount of energy supplied to machine get wasted in the form of heat energy while overcoming the force of friction. And I think someone asked me in the last class that is friction is generating the heat. So yes, because of friction heat is generated because friction is opposing the motion. So suppose if two machinery parts are rotating, so there is some friction between the surfaces. Yes or no? And that friction will oppose the motion. And if friction is opposing the motion, that means the friction is not helping that machinery part to rotate in the particular direction. So first that machinery part to overcome that friction, and in overcoming the friction some of energy is get wasted in the form of heat energy. Yes or no? Is this clear to everyone? Any doubt? Okay. Now second, wear and tear of objects. Yes or no? So friction is responsible for a lot of wear and tear of moving parts, and because of this we applied grease, we are oiling the machinery parts. Yes or no? You can see the chain of the bicycle is also get greased. Yes or no? We apply oil to many machinery parts. We apply grease so that the friction is reduced at that points. Okay, because friction is responsible for wear and tear of the moving parts. So it is the friction which wears out the surface rubbing against each other. Okay, you can see the difference here. This is the old tire and this is the new tire. So you can see there is a lot of gripping in the new tire, as compared to the old tire, because the tire is continuously in contact with the road, and if the if this tire is moving, so in moving the tire, the friction is opposing the motion. And you can also see, or you can also feel this by touching the tire, not touch instantly after the vehicle is stopped. After some time, you can see the tire is also heated up. Okay, so friction is responsible for wear and tear, and in friction also energy is lost in the form of heat. Okay, so moving parts of any machine need to be replaced from time to time because of the friction, because of which wear and tear take place. Yes or no? Any doubt?
No doubt, sir.
Okay, now I'll see methods of increasing friction. So somewhere friction is required for the better gripping. Yes or no? So whenever friction is required, it is increased by making the surface rough. Okay, so you can see these are the methods. You can see there are some grooves in the tire. Yes or no? There are some grooves in the tire, because of which to make this more rough, and so that the gripping can be increased. And grip can be increased by increasing the friction, and friction can be increased by increasing the surface roughness. Okay, so the treads and grooves improve the grip on the road. So this increases the friction to desired value and help us to avoid skidding or slipping. Okay, if tire becomes old, so they start skidding or slipping. That's why it is necessary to replace the old tire with the new tire. Okay, because if the tire is old and you applied the brake, so you want that vehicle to be stopped there. But as tire is getting old, gripping is getting reduced, because of which tires start skidding. Okay, is this clear? Yes or no? Again, you can see in case of athlete shoes, there are some spikes. Okay, so as to increase the friction. Yes or no? So sportsmen players are using special types of sports shoes with spikes on their soles. So this helps them to have better grip on the running. Okay, now how we can reduce the friction? So by making the surface smoother. And how we can make the surface smooth? So first one is by polishing. Okay, so when we polish onto the something, the surface gets smooth, and on the smooth surface we know the friction is less. Okay, so whenever we polish a surface, its roughness or unevenness get decreases. Okay, Isabel, any doubt? Isabel, any doubt? Yes or no? Okay, so after polishing, the surface becomes smooth and friction get reduced. Okay, so we also sometimes rub the surface with a fine and sandpaper to reduce their unevenness. Yes or no? Has everyone seen? Has everyone know what is sandpaper? Yes or no? Very good. Okay. Now, second one is the lubrication. So, when a few drops of oil are poured on the hinges of a door, the door moves much more smoothly. Yes or no? Sometimes we use oil in the machinery parts or in the moving parts, so that the movement can becomes easy. They can freely move. Yes or no? Why? With the help of lubrication, we reduce the friction between the surfaces in contact, which make the surfaces to move smoother. Okay, you can see these are the hinges here. Okay, and at the hinge points we do the oilings or greasing. Okay, so bicycle and motor mechanics use grease between the moving parts of these machines. Very good. Okay, you can see this. Has everyone seen this? Are you getting my point or not? Yes or no? Any doubt to anyone?
No doubt, sir.
Very good. Okay, so oil like substances which when put on a surface helps to reduce friction, which are called lubricants, which reduces the wear and tear. And if wear and tear is less, so that increases the efficiency by less wastage of energy. Okay, if there are less wear and tear, that means if wear and tear are less, so there is less friction between the surfaces are in contact, and if friction is less, so there is less opposition of the motion, and if opposition is less, so there is less amount of heat energy generated, and if heat energy generated is less, so we can say the efficiency is getting increase of the machinery part. Yes or no? Okay, so lubricants can be liquid like oils, okay, semi-liquid like grease, okay, third solids like talcum powder, okay. So these are the some lubricants which we use in reducing the friction between the surfaces, okay. Now we can use again by using the ball bearings. If you seen this, has everyone seen this ball bearings? So these are the ball bearings, okay, which you used in machinery parts. You can see this in bike, car, okay. So these are the ball bearings. So rolling up now here, which friction come into picture? Rolling friction. Yes or no? Because here, if these two surfaces are moving, so in between these two surfaces there are some balls. Yes or no? Now we know that rolling frictions are very less as compared to the static friction. Yes or no? And if we use balls, that means we are using the rolling friction, and rolling friction is less. Okay, so there is less wear and tear. Yes or no? Are you getting my point? So rolling friction we know is smaller than the sliding friction. Okay. So sliding can be replaced by rolling in most of the machine by use of ball bearings. By use of ball bearings. So we use ball bearings in shafts of motors, dynomes, axle of vehicles, etc. etc. Okay. So now whenever an object, now what is fluid friction? Okay. Now from fluid friction we will start in the next class, because if we start now we can't complete and you will get confused. I can't explain. Okay, so there's not enough time to explain fluid friction now. So we will start this fluid friction in the next class. For now, what we can do, you can log in into the platform. Everyone please log in onto the platform. Everyone please log in onto the platform. Okay, till now, anyone having any doubt in the lecture, today's lecture? Anyone having any doubt in today's lecture? You can ask me. Okay, what about others? Kevin, Hamizai,
Yes, sir.
any doubt, beta? Kevin, any doubt?
Sir, I have one doubt. I'm not able to understand the difference between the rolling friction and sliding friction.
Okay, okay. Suppose there is a table. Okay, suppose there is a table, and on table we place a book. Here, suppose
Okay,
there
sir.
is a table and I place a book there. Now I'm applying a force to move this book. So is the surface of the table and the book are in contact here?
Yes, sir. They are in contact.
Very good. Now if I'm applying the force and if this book is not moving, that means there is a friction force between the surface of the table and the book. Yes or no?
Okay. Yes, sir.
Why this book is not moving? Because some force is opposing the force which I applied on this book. Yes or
Yeah.
no? And that opposition force is called friction force. So here, if this book is not moving, that means friction is acting between the two surfaces is sliding friction. Sorry, static friction. You are confused between sliding and rolling, or static and rolling.
Uh-huh.
Beta, what is your doubt? What was your doubt?
So my doubt was that I was not able to understand the difference between sliding friction and rolling friction.
sliding and rolling.
Yeah.
Okay. So suppose I apply a force here. Now this book starts moving. Okay. Now if this book is moving, so the friction acting between the surface of the table and the book is sliding friction. Clear?
Yes, sir.
Initially, if this is not moving, so the friction is static. Now this starts moving. So that means the friction is between the book and the table is sliding friction. Okay. Now what I do, I will add some wheels here. I'll add some wheels here. Okay. I will add some wheels. Can you see in the diagram?
Yes, sir.
So suppose initially if force required is 5 Newton to move this book on this table. Now after adding the wheel, is the force required is same to move this book?
Yes, sir.
Yes or no?
Yes.
Anyone else? Please tell me. Initially, if I am applying a force of 5 Newton to make this book move, now after adding the wheels, is the force required is same to move this book? Yes? Tell me. After adding the wheels, is the force required is same? Yes, Isabel, tell me. Sudipti, Pubina.
Sir,
No, sir, it won't be same.
it won't be.
Very good. Okay, Kevin, tell me if you have a bag lying on the ground, if I tell you, suppose the weight of the bag is 10 kg and I'm saying you to pull it. Okay, so you're requiring some amount of force to pull it. Kevin, Kevin, are you there? Kevin, Kevin, are you there? Okay, you can unmute yourself, Kevin.
Sir, for the test, can you just send me the link, that link for the practice?
Okay, so first understand the difference between the sliding and the rolling friction.
Yes, sir.
Okay, so suppose there is a bag lying on the ground and the weight of the bag is 10 kg, and if you want to pull this bag, so suppose the force required by you is, let's say, 20 Newton. Force required by you is 20 Newton. Now this bag is sliding on the ground. Okay, that means friction between the ground and the bag is sliding friction. Yes or no? Till now, is it clear?
Yes, sir.
Yeah.
Yes, sir.
Very good. Now tell me, if we are on the same ground and if we are having the same bag of 20 kg, but this time at the bottom of the bag, I'm adding wheels. I'm adding wheels to the bag. Now to pull this bag,
Then the friction, the physical effort we put will be less because because due to the like a rolling structure of the wheels, we are easily able to push it.
very good. So that's the difference between the sliding and the rolling friction.
Yes, sir. Thank you, sir. Thank you for making me understand it. Thank you.
Thank you, beta.